Here is pre-calc, the second part of the homework for 4.1. This is the single sheet of paper that I handed out today in class. It starts with, that says the remainder theorem. We talked about how do you find the remainder without doing synthetic or long division. All you do, these are very easy, you take, if the degree in the leading coefficient of the divisor, this is the divisor, if it's a 1, so the degree is 1 and the leading coefficient's 1, you
1212.
take,
Mr. Forbert, please call extension 1212. Thank you.
you take the opposite of this number, which would be 1, and you're going to evaluate this for f of 1. So you've got 1, this is a 30 to the 30th power, I'm sorry, it's a 10, it's a 10. It's 1 to the 10th power, 10 or 30, it doesn't really matter, plus 1 to the 8th power, you're going to get a 1 plus 1, which is 2. This is a 10. From far away, it looked like a 30. So 2. Then number 33, you're going to plug a negative 1 in here. 3 to the negative 1 to the 4th power minus 6 times negative 1 cubed plus 2 times negative 1 minus 1. So a negative 1 to an even power is a 1, and 1 times 3 is 3. This is going to give you a negative 1, negative 3 is going to be a positive, or negative 1 times negative 6 is positive 6, and then minus 2 minus 1. So this is 9, and then minus 3, which is 6. Number 35, you're going to plug negative 2 in here, negative 2 cubed minus 2 times negative 2 squared plus 5 times negative 2 minus 4. So you have negative 8. This is going to be 4. 4 times negative 2 is negative 8. And then minus 10 minus 4. So you have negative 16 minus 14 is negative 30. And the last one in the set, 37, you have to evaluate f of 10. You're going to do 2 times 10 to the 5th power minus 3 times 10 to the 4th power plus 10 to the 3rd power minus 2 times 10 squared plus 10 minus 8. So this is a 1 with 5 zeros. So it's a 2 with 5 zeros. 1, 2, 3, 4, 5. So 200,000. Minus, we have, this is going to be a 1 with 4 zeros. So 3 with 4 zeros. 1, 2, 3, 4. So 30,000. And then this is going to be a 1 with 3 zeros. And that's going to be a 2 minus 2 with 2 zeros. And then what's 10 minus 8 is 2. So let's see, let's do this a little bit at a time. 200,000 minus 30,000 would be 170,000. Okay, and then plus 1,000 here would be 171,000. And then minus, this would be minus 198. So what we have is 171,000 minus 198 gives us 170,802. Next, it says, use the factor theorem to determine whether h of x is a factor of f of x. So what you're going to do is you're going to plug in a 1 here. 1 to the 5th power plus 1, and you're going to get 1 plus 1 is 2. So therefore, since the remainder is 2, this is not a factor. Not a factor. You can say no or not a factor. The remainder would be 2. For 43, you're gonna plug a -2 in here, -2 cubed minus 3 times -2 squared minus 4 times -2 minus 12. You get -8 here. This is 4 minus, this is gonna be minus 12 plus 8. These are gonna cancel. And this is gonna be -12 minus 12 is -24. So again, no. Next, you're gonna plug a 1 in here. 14 times 1 to the 99th power minus 65 times 1 to the 56th power plus 51. This is gonna give you a plain old 1, so 14 times 1 is 14, minus 65 and plus 51. These two add to be 65 minus 65 is 0. So yes, this is a factor of that, it goes into it evenly. Okay, on the back side, number 51, they're giving you these zeros, -2, -1, 1, 2, and 3. You're gonna write this as f of x. How do I know it's f of x? I have two variables here, so I need a y and an x. In factored form, it's gonna be x plus 2 times x plus 1 times x minus 1, x minus 2, and x minus 3. You don't have to factor this out. Multiply it out. The next one, you have -1 is a 0, so it's x plus 1, x minus 1, x minus 2, and x minus 3. Now, don't forget y equals, and you may want to put this one in front. So start with x, and then x plus 1, x minus 1, x minus 2, and x minus 3. They're both correct. Number 55 through 58, well actually 55 and 57 on this, there's more than one answer, one possible answer. Well, this one, there's only one answer. If the degree is a 3, they say n is 3, that's the degree, and I give you these 3 answers, your polynomial will look like this: x minus 1, x minus 7, and x plus 4. That's a degree of 3. That's the only answer it could be on that one. But for 57, it says the degree is 6, so you could have different answers for this one: x minus 1, x minus 2, and x minus pi. Now, we want the degree to be 6, so if I count each of these twice like that, that's one possible answer. What I could do is turn this into a 4, and then x minus 2 and x minus pi. That's another possible answer. Okay? For 61, what I would do for this one, it's asking you what k is, so that this goes into it evenly. So what you could do is you could evaluate this for, if you plug -2 in here, so you have -2 to the 3rd power plus 3 times -2 squared plus k times -2 minus 2. You want this remainder to be 0. That's one way of doing it, or you could do synthetic division.
Mr. Exel, if you're in the building.
-2 cubed is -8, plus, this is 4 times 3 is 12, minus 2k,
Please call extension
minus 2.
15. Thank you.
So this is 4, and 4 minus 2 is 2. You have 2 minus 2k equals 0. Subtract 2, and k is equal to 1. So if k is 1, you have, this goes into that evenly. You could have used also synthetic division and plugged -2 outside and done it that way. And same with this one. You're going to plug a 1 in here. So 1 is in for x. So you can evaluate, you've got k squared, and then 1 to the 4th power minus 2 times k, and then times 1 squared and then plus 1. And you want this to equal 0. So this is going to be a 1, so you have k squared minus 2k, and then plus 1 equals 0. And what would k have to be? K would have to be, if we put a 1 here, you're going to solve this for k. So you can use, you want this to be 0.